Have you ever really thought about it? The incredible journey a single ray of sunlight takes just to power your life? Well, today, we're going to break down the entire architecture of solar energy, all the way from that distant star right down to the light switch in your home. Understanding this whole process is, honestly, the key to unlocking a cleaner energy future. So let's just dive right in. It really all boils down to this one question, doesn't it? We're going to follow that single beam of light on its journey and see exactly how we managed to capture it, convert it, store it, and then use it in some surprisingly simple and some brilliantly complex ways. And of course, that journey begins about 93 million miles away. Before we can even start talking about solar panels or batteries, you really have to appreciate the sheer, mind-boggling scale of the power source we're actually dealing with here. I mean, just let that sink in for a second. The amount of raw, untapped energy that hits our planet from the sun every single hour is staggering. This isn't some scarce resource we have to fight over, it's literally the most abundant one we've got. The challenge has never been about a lack of power, it's always been about how we collect it and put it to work. Okay, so what is this energy really? Well, it's called solar radiation, and you can think of it as just a constant stream of energy particles traveling from the sun. This radiation is the raw material for everything that follows. It's the fuel. All right, now we get to the cool part, the tech. How do we actually catch this radiation and turn it into something useful, like electricity? Well, that journey begins with the absolute heart of modern solar power, the solar cell. So meet the solar cell. You'll also hear it called a photovoltaic cell, and the name actually tells you everything you need to know. Photo for light and voltaic for electricity. This little device basically performs a kind of modern-day alchemy, turning sunlight directly into an electrical current. It's pretty amazing. And what's wild is how simple the process is at its core. When sunlight hits the cell, it's kind of like a cue ball smashing into a rack of billiard balls. It just energizes electrons and knocks them loose. The cell is specially designed to then herd all these newly freed electrons in a single direction, and that controlled flow is electricity. Simple as that. Okay, so we've made electricity. Awesome. But that brings us to the most obvious question in all of solar energy, the one everyone always asks. What happens when your main power source just disappears every single night? Exactly. A solar panel that only works when the sun is shining is, well, it's only half a solution, isn't it? For solar to be truly, truly reliable, we desperately need a way to bottle that sunshine for later. And this right here is the critical missing piece of the puzzle for a 24/7 solar-powered world. Solar energy storage systems. Everything from the batteries in your house to these massive grid-scale projects. They're all designed to do just one thing, save the power we generate during the day so we can use it at night. And get this, storage isn't always about complex, high-tech electronics. Take a solar pond, for instance. It's basically a giant thermal battery. It's just a big body of salt water that collects and stores the sun's heat. The heavy salt at the bottom traps that heat, which can then be used to generate electricity long after the sun goes down. It's literally a giant natural battery. But solar energy isn't just about making electricity. Some of its most powerful applications are actually much more direct, just using the sun's heat to do the work for us, right on the spot. Think about the solar cooker. In its simplest form, it's nothing more than a well-insulated box with a reflective lid that focuses sunlight inside. It's such a perfect example of low-tech, high-impact design that uses solar radiation directly to cook a meal. And the best part? Zero fuel costs, zero emissions. You've probably seen these around. Solar water heaters use collectors up on the roof to absorb the sun's heat, and then they transfer it to water that's flowing through pipes. It's an incredibly efficient way to handle one of the biggest energy hogs in any home, making hot water. And we even use solar architecture to grow our food. A solar greenhouse is specifically designed not just to let light in, but to actually trap and store the sun's thermal energy. This creates a warm little bubble for plants, even when it's freezing cold outside. And there are basically two main ways to do it. Passive greenhouses are all about smart design, using things like south-facing glass and materials that soak up heat. Active systems, on the other hand, take it a step further. They use fans and pumps to mechanically move that solar-generated heat to exactly where it needs to go. So, when you look at the whole picture, from capturing radiation with a tiny solar cell, to storing it in a pond of salt water, to using it directly to cook a meal or grow food, We've designed this complete architecture for living with our star. The only real question left is, what are we going to build with it next?